In this video, we're going to look at chemical reactions. Now, it's important to remember that we've already talked about physical change, and now a physical change is different to a chemical reaction. An example of a physical change is if I have liquid water and I heat it up and the particles get more kinetic energy, it will turn into a gas, into a vapor, so it is still water. Now, if I capture that vapor and cool it down, it will go back to being liquid water, still water. And then if I take that liquid water and I put it into a freezer and the particles cool down, they're not moving as much, it will become a solid ice cube. It's still water though. So that is a physical change. Now, when we talk about a chemical reaction, it's when one or more new substances are formed. So an example like in the picture here, this is a burning sparkler and it goes from being this light grey material on a stick to sort of black and crusty, there's white smoke. So I actually end up with new chemicals at the end. So these and their properties are completely different from the original sparkler. I can't reburn my sparkler. So the reaction also produces heat, light and sound when you burn a sparkler. Another example of a chemical reaction is the rusting of iron. So I can't reverse that. So the big thing to remember with chemical reactions is they cannot be easily reversed, and in some cases they can't be reversed. But a physical change can be reversed. So when you're looking at something like an iron nail that's rusting, you've ended up with this new brown substance. The properties are different from that original grey iron. We try and stop rusting in some cases. So for example here, on things like boats, they will paint them with very thick paint, and that's to try and stop moisture touching the metal and having it rust. So again, physical change can be reversed. Chemical reactions cannot be easily reversed. Now there's several signs that a chemical reaction has taken place. So the first sign is a gas might be produced. Now we've done chemical reactions in the lab where, for example, you will put magnesium into hydrochloric acid and you can see that there's bubbles being produced. You can also feel that it's an exothermic reaction, so the test tube gets hot. But going back to number one, so one sign of a chemical reaction, it doesn't mean that all of these happen every time, but one sign of a chemical reaction is gas being produced. Another is a permanent color change may occur. A third one is a solid is formed. So these are things called precipitation reactions, which you'll learn more about those in the future years. We can have heat, light, sound, or electricity being produced. And another one is a change in mass from what we started with. Now, the next video I'm going to make is actually something called the law of conservation of mass. These things don't disappear. But for example, if I burn my piece of wood down here, but before I burn it, I weigh it, and then I pick up all the coal I'm left with at the end and I weigh it again, it's actually going to have a lower mass. But that stuff hasn't just become nothing, it's gone up into the air, there's been ash, it's broken down. But you can definitely see when I'm burning wood, there's definitely a permanent color change, there's heat produced, there's light produced, and there'll be a change, like I said, in that mass. This is another example of an experiment here. This is actually what happens when you put sugar into sulfuric acid. There's plenty of YouTube videos you can watch on that. This video here is a demo that a few of us did in the science lab. And this is another one here where we put a gummy bear into potassium chlorate. Now this one has to be done in the fume cupboard because it does produce fumes that aren't very good for you to breathe in. But you can see in this reaction, so this is a gummy bear into a liquid, and you can see all this light that's being produced. So a large amount of energy is released in that chemical reaction. There's another video here you can watch on what we call elephant's toothpaste, but in this video they call devil's toothpaste. So it's an oxidizing reaction, an oxidation reaction, so lots of oxygen gets released, and that's what makes all the bubbles go up really, really fast. And there's another one here of a slow-mo video. I'm pretty sure this one was Mentos into soft drink. Now I've got down here, when you watch this video, I would like you to describe the chemistry of cookies. So it's a very good video explaining chemical reactions and how when we cook food, chemical reactions are taking place. And then there's some language we need to know before we get into things like balancing chemical equations and some more experiments in class. So the two key words when we're talking about a chemical reaction is that we have sort of two groups that we talk about. We have the reactants. Now the reactants are the substances you start with. Now these react with each other to make products. So these are new substances that are produced at the end. So here you've got the classic volcano experiment, and this is actually the chemical reaction that creates, that people use for this fun sort of making a volcano. So the chemical equation, which is a shorthand way of describing a chemical reaction, is we have vinegar and baking soda. So this part at the top here is called the word equation. So it's the vinegar plus baking soda, and it's an arrow. It's not equals because it doesn't turn into vinegar and baking soda. There's a chemical reaction that takes place, and the vinegar and baking soda actually reacts to produce salt, water, and carbon dioxide. So the bubbling up is that carbon dioxide being released. Now, when you actually look at the molecules in this, so we've talked about this, so these are molecules that are made up of different atoms. So you've got in this molecule here, this is acetic acid, so it's a compound because it's made up of different types of atoms. Now it's got C2, which means it's got 2 carbons, H4, which means it has 4 hydrogens, and it's got O2, which means it has 2 oxygens. So when you look up here, you've got the 2 carbons, the H2O, you've got 1, 2, 3, and there's 1 around the back there, and then you have the 2 oxygens. That reacts with sodium bicarbonate. So sodium is Na, you've got hydrogen, so there's your hydrogen, you have a carbon again, and then you have 3 oxygens. So this is a molecule of sodium bicarbonate, and they react to produce sodium acetate, water, and carbon dioxide. And the big thing to look at, and this is what I'll talk about in more detail in the next video, is the law of conservation. As I said before, the chemical reaction does not lead to stuff just disappearing or spontaneously coming into being. The atoms I have at the start, I have at the end, they've now just changed into new molecules or reacted to produce new molecules. So if you have a look, there's 2 carbons in this molecule and 1 carbon in this one. So that's 3 carbons. And when I come over here, I've got 2 carbons and 1, that's 3 carbons. Then I have a look here and I've got 4 hydrogens, 1 more hydrogen. That means on the reactants, there's 5 hydrogens. Over here, I have 3 hydrogens and 2 hydrogens. So that's 5 hydrogens. I have 2 oxygens and 3 oxygens. That's 5. 2 oxygens, 1 more is 3, 2 more is 5, and then I have 1 sodium and 1 sodium. So this is a balanced chemical equation. There's no new atom suddenly appearing at the end, and there's no atom that's disappeared. All the atoms I have on my reactant side are in my products. I now just have new chemical molecules that are being produced by the reaction. Now we've got some more. These are really cool videos. This is the video. It talks about, it's got helium that obviously makes your voice go very high pitched. Then it's got other gases that make your voice go very deep. This is one of my favorite chemical reactions to see. It's the iodine clock, which changes very, very fast. So it's a really cool video for you to have a look at. And then this last thing I just want to talk about here is when reactions occur, and not all chemical reactions are good or bad. So there's reactions we want to take place, and then there's reactions we sometimes want to stop. So chemical reactions only occur under certain conditions. So iron won't rust without air and water. So in theory, if this boat had sort of it got shipwrecked and half of it was buried under very, very thick mud and there was no moisture in there and there was no air getting down to it, it shouldn't rust. But of course, this part of the boat that's exposed is exposed to air and it's exposed to water, so over time it's gone rusty. Same sort of idea, things that go on the moon doesn't have atmosphere, so there's no oxygen or water, things shouldn't rust on the surface of the moon. So you've got you often need heat to cause a chemical reaction, and if you don't even need heat, often what heat will do is make a reaction faster. So if you think about it, if you're trying to, say, dissolve sugar into water, if you stir sugar into cold water, it will eventually dissolve, but if you stir sugar into hot water, it will dissolve much faster because it's got more energy, more chances for collision, and it will dissolve quicker. So other chemical reactions that use heat, so when we eat eggs, we cook them first, and you can actually see that for example, the white part of the egg is sort of clear when it's in the egg, but when you cook it, it goes white. As we talked about before, sparklers burning. Sometimes you can need electricity for a reaction to take place, so to charge a car battery, and so your car battery's got acids in it, and the electricity produces changes in the chemicals inside your battery. Now, as I talked about before, we have wanted and unwanted chemical reactions, and we do different things to either make these happen or to make them stop. So we want photosynthesis to happen. It's a chemical reaction that happens in plants and they produce food. We have chemical reactions in our body that help us digest food. So you've got enzymes in your mouth, in your saliva, you've got acid in your stomach. So it's all about breaking food down. We want reactions to do things like make rubber and plastic and detergent and paint. So there's lots of reactions we want to happen. And then reactions we try and stop. So things like rusting, tooth decay. So by cleaning your teeth, adding fluoride to our water, we're trying to stop tooth decay. We try and come up with ways to stop pollution being produced. So once you've gone through here and done some of those questions and watched the videos, there's some more questions down the bottom for you to do here. So there's questions for section 5.2 and 5.3, which you can scroll through and complete.